rational function, you can use this trick right here. If the degree of the numerator is less than the degree of the denominator, then the limit as x approaches infinity is 0. See, that's different than over here. So here we have a set value for c, but this is if x is approaching infinity. So let me write that. If x approaches plus or minus infinity. Okay. So if x is approaching negative infinity or positive infinity, the degree of the numerator is less than the degree of the denominator, then the limit is 0. If the degree of the numerator is equal to the degree of the denominator, then you need to take the ratio of your leading coefficients as your limit. So say you had 2x squared plus 1 over 3x squared, your limit would be 2/3, because that's the ratio of these leading coefficients. Alright, and if the degree of the numerator is greater than the degree of the denominator, as in your final limit as x approaches plus or minus infinity, then the limit does not exist. So if you're wondering what a degree is like this number right here. It's the highest exponent value in the equation. So say you had 3x to the 4th plus 2x squared plus x, your degree would be 4, because it's the highest value exponent that you have. Alright. Now to find horizontal asymptotes, use the same rules that I taught you for limits approaching where x is approaching negative or positive infinity. Remember that if the degree of the numerator is less than the degree of the denominator, then your horizontal asymptote will be at y equals 0. If the degree of the numerator is equal to the degree of the denominator, then your asymptote would be y equals the ratio of your leading coefficients. And if the degree of the numerator is greater than the degree of the denominator, then you don't even have a horizontal asymptote. And if you're wondering what a horizontal asymptote is, it's just like a vertical asymptote, but horizontal. So see how you have this vertical asymptote right here at x equals 0, and these two lines keep approaching the x equals 0 line without touching it? Well, the horizontal asymptote right here is at y equals 2, because these lines are approaching this horizontal line without actually touching it. So if the degree of the numerator is probably equal to the degree of the denominator here, and it's probably something like 2x over x. Like that would be an example of having horizontal asymptote at y equals 2, because the ratio of your leading coefficients is 2 to 1.